My name is Matteo Lanati. I work at the Leibniz Supercomputing Centre in Germany. And today I'm here to talk about budgeting and our experience and why we need that. Before starting, of course, thank you very much for the invitation and for including us in your OpenNebula Champion program. So this is the outline of my my presentation. A short introduction on my institution, an update on what we did last year, then the core of the talk, the budgeting, why we need it, what's our approach, our ideas, our current status, and what are the next steps for our OpenNebula deployment. The Leibniz Supercomputing Centre is part of the Bavarian Academy of Sciences and Humanities. We are based near Munich. We mainly work with the two universities in the city, namely the Ludwig Maximilian and the Technical University. But we also operate at a regional level, cooperating with the State Library. At the national level, we are part of the Gauss Computing Centre, which is the national initiative for supercomputing, putting together the three biggest centers in Germany. We are involved in many EU projects. Here I mentioned PRAISE. And if you want at a larger scale, we also commit resources to RCG and other big projects. We mainly provide traditional IT services to the university, namely email, user management, web hosting, and so on. But we are also quite involved in high-performance computing, and this is our machine, SuperMOOC. It has been deployed in two phases. The first one dates back to 2012, and the other one is more recent with a different architecture, where they are more or less both capable of providing 3 petaflops per second. We are in the top 500, I think around position 30. And 1.5 years ago, we also started to provide cloud as an infrastructure as a service using OpenNebula. Of course, in this case, our infrastructure is smaller. We have more or less 90 physical nodes for a total of 700 cores and 7.5 terabytes of RAM. We have one front end with 8 cores and 32 gigs of RAM. It's a VMware virtual machine running in high availability. This has been enough to serve all our users. Of course, the front end, it's where the one daemon is deployed and where also Sunstone is deployed. So far, it has been enough. Regarding the storage, we use NetApp. It's mounted on the node as an NAS. We have a total of 300 terabytes that we use both for the data store and the system store. An update on last year's activity. Here I'm starting looking at our user base. As I said, we mainly cooperate with the universities, so it's interesting for us to see the scientific background of our users. So what kind of science they are doing. Here I'm comparing two periods. The first one is March 2015 when we started to offer OpenNebula to the users till October 2015, basically when I came here the first time. And the second period is, well, the next year. At the beginning, so in the first period, we created more or less 200 accounts. The distribution is, well, you can see it here. You can see that this category other is predominant. We have quite some internal use. It was basically us for testing and some colleagues to try out things. Math and computer science, it's, well, 15%. It's not a lot. It was not a lot. And also the bio community is let's say, relevant, and they were quite vocal to ask for this kind of service, basically because they wanted to use software that was distributed as a VM image. The following period, we created 250 accounts. Hopefully, this category, well, reduced. It always sounds a bit bad classifying as other and seeing it as predominant. But more or less 1/3 of the accounts are internal, and there is a reason. Basically, here we have a lot of accounts used for training, because we offered a couple of trainings for our users, one in 2015 and one in 2016. Computer science, well, it's another third. Well, it's kind of expected. These are our target users. And we also have mechanical engineering, which is quite relevant, and, well, let's say that this kind of faculty is quite predominant in our universities, so it's also expected. Same here regarding the use of the resources. In the first year, we provided more or less 1 million CPU hours. Our biggest user was the geoscience community. They ran quite a couple of simulation runs, quite big, booking 70–80% of our resources. In the following period, we provided 3 million of CPU hours, which is quite good from our point of view, meaning that people are really using it. You see the geoscience community, well, more or less they are computing the same amount of time, but their impact is reduced. And of course, the main role, the leading role is, again, computer science with more or less 1 million of CPU hours. Regarding the storage use, we started with 10 terabytes. I mean, this is the sum of the images stored by the users. And again, we have an increase of 3 times. So from 10 again to 30 terabytes. This was a bit surprising for us. We didn't expect this. The reason is that basically with our cloud, we are filling a gap in the services that we are providing. So we have quite established solutions if the scientists need to store and share small amount of data, small meaning up to 100 gigabytes. We also have turnkey solution if they have a big amount of data. And here big, I mean 100 or 200 terabytes. But if their need sits in between, well, we don't have an established solution. So if they have to process, let's say, 1 or 2 terabytes, which is, I would say, quite common, well, they have to store it on the cloud. And yeah, this is the reason of this increase. Okay, budgeting. So the main topic of this talk. What's the goal of this? Well, we want to achieve efficient use of resources, minimizing the number of idle VMs. The reason is that our cloud is mainly a compute cloud, so we want people running simulations. We do not overcommit, and of course, it's very important for us that unused VMs are undeployed or shut down. In fact, if some VMs are misbehaving, for example, we have VMs that are computing heavily, running on the same node. Usually users realize it and we get a phone call. Yeah, so this is the reason why we want to use resources as efficient as possible. By budgeting, we mean the possibility of manage or limit the lifetime of a group of VMs. Of course, we don't want to limit the lifetime of the single VM, setting a maximum running time, because, well, we don't really know what a user wants to do. For sure, we want to give a maximum amount of time that then the user can decide how to employ it. Running a lot of VMs with a small number of cores, or the other way around. And the criteria that we use to compute the budget. Well, we take into account the number of cores, of course, the RAM of the VM, the data store space, so the space used for the images, not for volatile disks. The number of IPs, since we also provide public IPs, IPv4, limited resources, so we want to be careful. And of course, time. So all these things are then multiplied by the running time of the VM. This boils down to define a cost function, that is finding the weight, the cost, or the coefficient of each of these parameters as specified here. And, well, this is the tricky part. Let's say that after 1 year or 1.5 years, we have reasonable knowledge of the usage of cores and RAM. So we more or less know what our users expect. Regarding the cost of the coefficient of the data store, it's a bit trickier. The thing is, our colleagues that are providing us with the NAS are also offering space to the users. So if we are too cheap, then the users will tend to use our cloud to store data, which is out of our scope. We want to avoid it, but at the same time, it can't be too expensive. Otherwise, it's a problem for the users. And I mean, we want our users to do science and not to cope with this. Well, this is a proposal of the costs or the weight for each of these components. Basically, we came up with these numbers, doing a sort of trial and error. So trying different coefficients and compare it to commercial clouds. So we don't want to be again too expensive, even because we are a public service and we also receive public funds. So it's okay to cover some costs, but we don't have to earn money. What are the use cases that led us to this kind of model, or led us to think, okay, we need to address this problem? Well, the first case is computational bursts, and here I mean, for us a burst is usage of 200 to 400 cores. This is what we have been requested, and it's more or less 50%, up to 50% of our resources for a period of time that can go from a few weeks to few months, usually not more than a couple of months. So when we have this kind of request, we should be able to accommodate it. Of course, not on the spot, but yeah, in order to run this kind of simulations, we need to clean up unused VMs, and we need the criteria. The second use case is multi-tenancy inside a group of a project, where here I mean supporting the training of students, supporting our university chairs in student training. Some courses require students to work on VMs and deploying some I don't know, small clusters and so on. The cloud is very convenient from this point of view. What the university or the chair wants to avoid is budget overflow. So we agree on a certain quantity of resources, then users run VMs for more time, and while they want to avoid that, we go back to them with a bill saying, hey, you have to pay this extra, and so on. Then this kind of approach is also useful for us to do management and planning, see what we need, what we have to buy, and then, I don't know, nodes with more RAM rather than more cores. Yeah, so it's kind of a measurement. What's our plan? Well, we want to have, in the end, 2 hardware classes. One is regular, so it's hardware bought by us, using public funding available for our users. And the second class of hardware is what we call reserved, and it's hardware brought in by the user. This doesn't mean that they have some spare material and they can bring it to our computing center. This has to be agreed, but basically this hardware is bought by the users with their funds. This fits quite well it can sound a bit strange, but it fits well with the funding model of projects. So maybe a chair or a project receives money that can be used only to buy hardware, so they can't compute CPU hours or simply computing resources from us. They need to buy hardware, they need to put a label on it, and they have to be able to say, hey, this is my hardware. The provisioning model is very similar to hosting, but it's a bit better. So we are not very fond of hosting, because the users want their operating system, and we can end up having to support multiple operating systems, installing patches, and keeping track of these things. We want to avoid it. So the cloud is a good solution, because we install and maintain the operating system on the hardware. We stick to our SUSE enterprise. We are happy. We know it. And while the users, they can deploy whatever they want on their VM. We also think about having 2 user classes. The first one is the normal user, regular users. Well, they don't have a guarantee on the start time, so they launch their VM if the cloud is full or there are not enough resources where they are just in queue. What is guaranteed is that their VM is not interrupted, so we can't kill the VM unless there is a problem. And the second class of users is what we call privileged, and in this case, they should be able to start immediately their VM. And as you can imagine, this is the mapping. So the regular user just the normal user go to the regular hardware, while the privileged users are basically the owner of the reserved hardware. So they buy the hardware, we deploy it, we maintain it, but they have to be able to access it whenever they want. Of course, at the first approximation, there is exclusive access, which is kind of a waste. So if they're not using it, the hardware is idle. This is a consumption problem, of course. But it also, let's say, goes against the idea of cloud. And this is why we would like to introduce at least another class of user, the so-called interruptible. And they run on the reserved hardware when it's empty. But of course, when the owner comes in, they are kicked out. And in this case, well, we optimize the usage. So there is always something running here. And the second, at a later stage, we can also think of opportunistic users filling the gaps here in the regular hardware. So this is where we want to go. This is what we want to achieve. How to do it? Well, I think that we can manage the user classes via the template. So they could specify in the template what kind of profile they want to use. And here there are some possibility to customize the Sunstone with a drop-down menu, something like that, to help them decide. Regarding the hardware classes, well, for the regular, there's nothing to do. For the reserved, how can we handle this? Maybe using the permissions, ownership, ACLs, and so on, so that the hardware can be used only by the owner. I think that also the scheduling requirements can be helpful. So if the owner specifies a certain tag that matches the template of the node, then it can be deployed. But if you want really some advanced features such as filling the gaps and so on, then we have to work on the scheduler. This is pretty clear. What are the important features that we are looking for? Well, we think about a prepaid model, so we assign a budget to a user, to a group, in our case. And what we want really to avoid is the budget overflow, because it has to be clear. We can't go back to the user saying, hey, sorry, you consumed more and you have to pay an additional bill. That doesn't work. And of course, when the budget is exceeded, then the VMs are undeployed. And there are warning emails and so on. Then the users can come back to us, and so we can agree on a solution. We are looking for an external implementation, basically because we want to split this, not the budget management, the budget allocation, and the sysadmin view. So here I'm thinking about myself. I take care of the system. I don't want to know how the budget of a certain chair is assigned to projects and so on. Someone has to do it via another interface, and we have to import this kind of information. Because this is kind of dynamic, and we want to do it in an automatic way. We don't want to receive a phone call every time there is a change. Well, we started to implement something. We started from day one. This was a clear need. And day one, I mean 2 years ago. I know that OpenNebula supports, I mean, you can specify in the template the cost of VM, disk, and so on, but it's quite recent. We had to start it 2 years ago. So we created a widget in the dashboard with one number saying, well, your usage is X%. Very clear, very simple. We also added a menu here on the left, and if a user clicks it, well, you go to a detailed view where you see how many CPU hours and so on. And if you click on it, you see for each user what's the contribution to the usage. So we do not limit each user, but they can have an overview of who used the most, who used the platform the most. How it works? Well, when a user submits, well, it works by means of hook scripts and cron job at the moment. And of course, we only have the regular hardware. We don't have the privileged one. So when a user submits a VM, there is a hook script. It queries the database, where there is an additional table keeping track of the thresholds, the budget that has been assigned. And if there is enough budget to run the VM, then the VM goes through, starts to run. While it runs, there are cron jobs, I think every hour. We compute the consumption, so the cost function, which is quite easy, at least now at the beginning. It's number of cores multiplied by running time. And well, this information is stored again in the data store in another table. When there is no budget left, then the VM is undeployed. We check that it's correctly deployed, and an email is sent to the user. Of course, also this table is modified so that basically we change the ACRs, and if the user tries to submit again another VM, well, there is an error message saying, hey, you ran out of budget. Please contact this email address, and so on. Okay, next steps. Well, we plan to update to OpenNebula 5.0. We know that 5.2 came out. The thing is, we already announced the maintenance, which will be in a couple of weeks. So I don't know if we have time to test everything, that everything works in 5.2. We'll see. We plan to next year to upgrade the hardware, so buy new hardware. The size of our cloud will be more or less the same, but we want to have more recent hardware. So nodes with more cores. Probably we also plan to buy a few nodes with more RAM, because we couldn't accommodate some projects. We also think about the possibility to use to buy GPGPUs, since it's supported by OpenNebula, the pass-through. And then we also focus on security of VMs with an internal project that is called RZ Security Scanner, which is just been developed by a colleague of mine, and maybe it will be presented next year. So we want to detect weak passwords. That's quite important because, as I said, we run an infrastructure as a service. We don't have control on the VMs, but we want to be sure that things are done properly. And one of the most basic things is, well, people should have a password, first of all, and it should be reasonable. And then it's also interesting to identify vulnerabilities via Metasploit. So again, the idea, and it's more than an idea, it's already something like a proof of concept, is to add a hook script when the VM is started, then we scan it. Yeah, that's all from my side. Thanks.
Is there any question for Matteo? Yes.
Sorry, I'm late for the presentation, but can you do reporting on your budgeting?
Sorry?
Can you do reporting? Can you?
No, not yet. No. I mean, we have some dashboards in place and to see the usage, but it's more for our convenience.
Thank you. Thank you.
Any more questions? Okay, well, thank you so much, Matteo.